Hello friends, today we will discuss about a very important feature in the scikit-learn library, and that is a very important step in your machine learning tutorial. So that is called pipeline. So till now in our video series you have learned about the imputation method, the scaling method and the encoding method, right? Now you have the model algorithm as well. So when you are applying these all things to your data set, so then there is a possibility that you may jumble up the things. So the pipeline will ensure that you have defined a complete, traceable, clean workflow for your entire data set on all the application you want to do upon it. And second thing is, the clean code is now very much reproducible. It will enhance its reproducibility by defining all the steps clearly and sequentially. And the last thing is that when you are defining a pipeline, see, you have two kinds of data set. One is your trained data, another is your test data. So whatever application you are applying on your data set, if you apply it individually without using the pipeline, you need to apply it on both the data set. Like you want to remove the missing data, so you need to apply your simple imputer method or the KNN imputer method or the iterative imputer method on both the data set. And then whatever the transform data you received after fit and transform method, so you need to apply, you see, if it is a categorical data, now you are doing one-hot encoding method, for example. So you need to do it on both the data. And then when you're applying your model algorithm on the data, so then after all these steps, you need to fit your algorithm on the trained data, and then you can predict the dependent variable by your test data. So this is everywhere individually you need to fit and transform your data wherever you are applying a new application, and then you need to separate it out at the fitting the data in the estimator or the model algorithm, and then predicting the Y value from that model algorithm. So let's see with an example. So whatever you see in the screen, so that is actually defining it for a sample data. You are applying KNN imputer first, and then you are applying the standard scaler second, and if you are applying the random forest classifier as the last. So in that method, you need to apply fit and transform in all your data. If you apply pipeline, that will actually apply fit and transform sequentially on the input and output data set. The output or the transform data in this case of the KNN imputer will be fit and transformed with the standard scaler, and the end the random forest classifier will fit on the output of the transform data of the standard scaler. So this is the beauty, you are defining all the step by step, all the steps in the pipeline, and just you are applying the you are just fitting on the data set, and it will apply all the applications sequentially. And then when you test your prediction on your test data, you just don't have to do all these things again. You just need to use the pipeline.predict on your test data, and that will do everything on its own. So that's the benefit side of the pipeline. Now let's say you have categorical data as well as numerical data in your data set. So in that case, those columns which has the categorical data will be treated separately than your numerical data, right? Because by nature they are different. So in that case, you cannot do it parallelly. So that's a drawback. of the pipeline method. You can do it sequentially, but you cannot do it parallelly. Like you see, you want to apply the KNN imputer on the numeric data, and you want to apply the simple imputer on your categorical data. So you want to do these two things on the two set of columns in your data set simultaneously or parallelly. You cannot do it using the pipeline method. For that, you need to use the column transformer. We will check that option in the next video, but that is a main drawback of using the pipeline. You can do the application sequentially, but you cannot do it parallelly. Let's see our example. We have given a very simple, we have not taken any kind of data set. We just have our simple data set. We just want to learn our concept clearly, then going for any like very smart data set or that robust data set. Let's see our example. So first thing, I have this kind of data. Like I have 4 kind of animals like dog, cat, elephant and tiger. For all of the animals, I have defined, is it a domestic animal or is it a wild animal? So this is very simple data set, only 4 rows you have and only 2 features you have. And I have just given, like I don't know elephant is a wild animal or the domestic animal. So I have given the missing value here. So what I need to do, I have like categorical data, right? So this is a string data I need to convert to numeric. Before that, I need to take care of my missing value. So I just use the simple imputer method, and the strategy will be the constant, and I am replacing the nan value with the fill value missing. Then I just need to do the fit and transform both on my train data and test data. In the test data, I just use the same thing, and this time I use like dog as a wild animal. And let's see what is my y value. I want to predict the life expectancy of those animals. Let's see how it happens. So now I want to apply both the simple imputer both on the train and test data. So I need to define it, and I need to keep it in a variable, and then using the one hot encoding method, I need to transform this categorical data into the numerical data. So there I actually take, let's see what's the output of this. So I have like fill value is equal to missing and the strategy is equal to constant, and the output of this simple imputer is, let's see, I just give the xtrain only, and the output is, the elephant is now having the missing as the placeholder. Now when I get the one hot encoder, so this is the like categories will be auto and the handle unknown is equal to ignore. So that can be 2 types, one is ignore, another is error. I have just ignoring the unknown things. And now again, this is the drawback of doing the things individually. I need to use the output of these 2 variables here in the xtrain and xtest, and then I again need to fit and transform the one hot encoder and take it into some variable. Let's see what it is. I don't know why I am typing some wrong. Okay, so what it is saying, a sparse matrix was passed. Okay, to show you the data, I just need to use that sparse is equal to false, otherwise it will be a sparse matrix. All right, now I have why it is so. Yeah, now it is good. And you don't know why this 0101 is until and unless you have now all the features defined, the dummy features you have got. So now these headers are like cat, dog, elephant and tiger. So you have wherever the cat you have in your data set, so you have dog in your first row and domestic in your first row. Let's just check one data. So you have dog, like this is the second feature, so dog is 1 and for the first row, and in the last 3 row domestic is the last but 1, so this is 1. So this data is correct. So now I need the sparse matrix, so I just remove this sparse is equal to false is equal to true, and now I have my data. So now this is a sparse matrix and these are again the categories, and now I have the random classifier, and this is my like life expectancy, the y value of the trained data. And I have predicted for the cat it is 7 years, for dog it is 7 years, for cat it is 5 years, for elephant it is equal to 15 years, and for tiger it is 9 years of the life expectancy. And then I have defined a random classifier with n estimated is equal to 10, and I just feed my x train and y train data, and I predict my x test data to get my y test. So you see, this is so many steps. Now let's see the same thing using the pipeline. So from sklearn.pipeline import pipeline, and I just define my pipeline is equal to, and in pipeline definition what you just need to define, you just define the name of the steps and the steps. So steps is equal to a array of the application, and for each of this application it will be the first bracket, and I have like this is my first application, right, both on the train and test data. Just simply copy it here and give it a name. Like this is my simple imputer, so SI is the name. So this is one step. Let's go to the next step. In the next step what I am doing? I am doing the one hot encoder, right? Just copy that one hot encoder application here. And give it a name. Don't forget to give it a name. And then what is the next step? The next step is the random forest classifier, your model algorithm or the estimator. Just define it using a name. So I just use the same name, RFC. And then this is the like the application you have defined. Till now clear? Yeah. So now I have defined my pipeline and now use it to feed my data. So it's very easy. So now I just write pipeline dot feed on the X train and Y train. Okay, so this is using the old X train and Y train data. Let's give my data set again. This is the drawback of using the same variable, just remember. So I have given the data again. So now it will work. See, in the above, when you are doing it individually, you have predicted the life expectancy of this extra dog is 9. So that is matching with the tiger. So because it's a wild dog, let's see how it is happening here. So it's a very small data set, so don't go for the estimated accuracy. So just you give you like the how it works, and then you just need to write clf.predict and use your test data. And you see your test and train data is giving the same value. Got my point? So for this first dog it's 5. I don't know what it is happened, but let's ignore, because it's like your model estimator is as good as your data. So let's ignore the result, but see how simple. So your these many lines of code is actually concentrated in a very strategic and step-by-step manner in the pipeline. Is it a beneficial tool for you? Yes. So this will actually enable you to write the things in the proper manner, and it will reduce the manual error while you are coding. Thank you so much for watching this video. Please stay tuned on my channel to have more videos like this. This is a very interesting series we are going on the machine learning. Please stay tuned and please leave a like if you really like this video, and please subscribe for more videos like this, and please make sure you type in the comment section for your doubt and questions. Thank you so much. Stay tuned.